Video, we're going to talk about two different types of recursion, direct and indirect. We'll write code examples and code spaces to see how these types of recursion work and when you might encounter them. First off, what is direct recursion? Direct recursion is when a function calls itself directly within its code. We actually have done recently two examples of direct recursion, and you saw that in the last video with the recursive function and with factorial. Um, we call itself, this function calls itself, recursive function here, calls itself directly to calculate the sum of all numbers from the number we pass in to 0, and the factorial does something similar. It calls itself directly to calculate the factorial of our passed in value. This is direct recursion in action, because the function doesn't rely on any other functions to complete its task. It simply calls itself with a smaller value each time until it reaches the base case. When in our output, as we noticed before, you can see each subsequent call. Let me just run this by itself real quick, and you can see what happens. Okay, so for each call, we have a pass value, for example, of 3 in our program. We have a pass value of 3, and for each call, it goes 3, 2, 1. When it reaches the value of 1, it passes that back out, and it says, okay, now that I know what this is, I can know what 2 times 1 is. Now I can know what 3 times that value is. It correctly returns the factorial by calling itself with smaller values until it hits the base case. Now I'm going to add a new example here, and we're going to have a couple of functions, and I'll show you indirect recursion. Alright, so instead of you watching me type, I've typed ahead this time, and here is indirect recursion in action. So let's go ahead and what we're doing, right? But as you can see, I have a function A and a function B. And if you look in my function A is calling function B, and function A or function B is calling function A. Because these are calling each other, we are creating an indirect recursion. We have a base case in both, right? This creates an indirect recursion loop, which will continue until the base case is reached, in which n becomes 0 or negative. As you can see in this call, the functions alternate, calling each other until n reaches 0 or lower. Indirect recursion can sometimes be more complex to follow than direct recursion because multiple recursive functions are involved. Okay, so we're going to go ahead and run this function, and really I want to go ahead and do this for us. I want to go ahead and output to the console function a call, and we are going to say value, and then we'll pass in, right? Okay, and then inline. I'm going to do the same thing here for the function b call. So you can see this recursive function in action, and this is just going to be function b call in value and then the inline. Okay, so let's go ahead now and function b not declared. Okay, so to fix this problem, I'm just going to go ahead and simply throw up to the top of our script. Declarations for both of those functions, and that way it knows it's going to come, and we'll do it with this. All right, so here we go. Function A, function B, function A, function B, and you can see what happens until we reach a negative value. And if you see this is less than or equal to 0, so it stops the function call. All right. So direct recursion is involved in the more straightforward way, and it's used for problems like evaluating factorials, calculating Fibonacci sequences, or navigating data structures. Direct recursion also works with tree traversal and backtracking, but indirect recursion is useful as well because it can be used in complex logic or scenarios involving multiple interdependent functions, such as state machines or mutually exclusive conditions. Indirect recursions, while less common, are useful when determining conditions is important or interdependent functions are required. However, indirect recursion can become challenging to debug and understand because of the multiple calls involved. To recap, direct recursion involves a function calling itself directly, while indirect recursion requires at least two functions calling each other. Both types rely on base cases to avoid infinite recursion, which can lead to Stack Overflow errors. Understanding the difference between direct and indirect recursion will help you choose the right approach for different problems. You should practice creating your own examples and observe how each type behaves. Thanks for watching. We'll see you in the next video.